Hello and welcome to Section 8, Part 10. There will be no suffering watching me draw diagrams at the start of this video. We're going to go straight into the code. We'll be continuing on with assigning our group positions. These are going to be very similar, it's just we have different calculations. Like I said before, if it is the first one and it's not odd, so let's do that. So if spacing left is 0, that means we're on the first one. We haven't done anything. We haven't assigned, we haven't done this. We haven't done anything. And also, we will just want to double check that it's not odd. Because this is what we're going to do here is add the half and half spacing for the, like I said earlier, if you can remember that far ago. When we've got a formation position, so we've got a formation like this, we're basically saying this is the center position, and we want to add half the spacing there and half the spacing left and right to get that first position. So we're going to say spacing left. And we're going to just halve it. And we're going to add the group spacing as well. Like this. And halving that as well. So remember, this is the total spacing, and we're going to halve. We're basically halving the total spacing here and adding that to the left side. So for this one, just to be clear, if this is an even formation, we're assigning the position as the center, and then we're adding half left and right. Full spacing left and right. So we're going straight to the next position, straight to the next position. But for the center one, we only want a full spacing between these two positions. So we're adding half left and half right. I think I can explain that any better. We need to apply the spacing, or the offset. So our local offset position, we want to add our spacing. So that's adding the spacing to the position. So this local offset position is just a 0 or a 1. So it's adding, if our spacing is, if it's our first position, it's 250 or whatever, we're adding 250 to, to be, if it's, actually I can come back, very good time to show this one. We're coming back to this, it's -1 times 250 is -250, right? In the X, and -250, we're calculating this position. And in this case here, we're calculating the first position. So if we're doing our line formation, it's, -1 times the half spacing, and we're getting that position from the center. And we're going to invert, for the left side, this is only, we're going to invert that. And it doesn't really matter left or right. It's, as long as it's opposite when we do this one here, it's going to work, right? So if our value is 1 and we're really doing -1 and vice versa, you can almost think of these as not left and right, but one side and the other side. So this line here is what inverts this y value to this side. To the local offset position now, we want to rotate that to the rotation of the destination. Now, what the hell does that mean? So how can we do this one? So let's assume that this line here is our, can I rotate this line? If our destination is like this, and we want the formation to be like that, what we've done now is this is the center position. We've calculated our offset from the center, say it's there. And now what we want to do is actually, sorry, it won't be there. When we first calculate the offset, it's always going to be on the true y value. So it's going to be here. And if that's the direction we want to face, we're now going to rotate this vector. So it's that offset, but rotated locally to this facing. So it'll move the position to here. Yeah, let's go with that. So now we've got the offset for the next position. So let's add another position. So let's just copy this. And we'll change, so it's not going to be the center location anymore. It's going to be the center location plus the local offset. Rotation will be the same, offset's the same, that's all good. And this will be left side. These will make sense later on. Now that we've got that position, so we've got this position now. I'll did it on the right side, doesn't matter. So yeah, this would have been here, and then it got rotated to here. And then for the left side, we now want to add the rest of the rotation. So let's just go back to a color. So now for this position here, we want to add the spacing for the next left position if we calculate another one. So let's do that. And we want to add a full spacing, so I'm going to copy this. And that's that. So now the right position, we're going to copy all of this, bring it under here. We're going to take out the inversion, and we're going to swap all these spacing lefts for spacing rights. Don't miss one. So this loop that we're in here, we need to do for a non-alt. So if it's not alternating, left and right, so we just want to, if it's not the first position, so I is not equal to 0, then we want to do our spacing center. So it's not really spacing center, that was the name I used. It's sort of like spacing for not alternating. Like this. So if it's not the first position is just going to be the position. So if it's not the first position, then we're going to add the spacing, and then we're going to, same as what we did before, we're going to times it to the local offset. So that gives us our offset position from the start, and that's why we're resetting that local offset at the start, so we are continuously calculating the offset from the center position. And then I'm just going to copy this one, and we can do center side. Oh, actually I didn't change that to, where is it, right side. Actually, I think, oh, this is no side. Let's do no side here, because center side in sorry to make it confusing, but center side would be this position, center. All right, so that's slightly different to how we, oh, sorry, this is meant to be outside the loop. Yeah, so if it's the first position, it's basically going to skip this and use the location, and local offset won't do anything, right? It'll be 1 or something. So yeah, the number times 1 will be this location. And then the second time we come through for the next one, we're going to put the offset in like that. All right, so that's that one. So if we come back, we then are going to come back out and go into our assign formation positions. So the first thing we're going to assign is the group positions. And I'm going to, in this function, we're going to pass the navigation and selections. So let's create this function. All right, so now we want to, this is where we're going to get into assigning the positions using that brute force sort of calculation. So we are going to do min total distance. We just want this to be something high, so we're going to use the float max. Now we're going to build an array of indexes that we are using. And what the algorithm will do is shuffle these indexes so it can go through them and do all the calculations. So we're just creating I'm just going to populate that index array with the selections. Like that. Once we go through and shuffle those indexes around to find the best setup, then we basically want to save the best one. So we'll call this best. And I'll just put a note here. Typing. All right, now we want to do while loop. And in that do while loop, we are going to do, we're going to call a function for the, in this, we're going to pass that index array. and we need to pass it as data, and we're passing our selections.num, so how many positions we're doing. Now, I'll get into this in a minute, but in this do loop, we're going to need a distance. So that's the sum of the distance for this permutation. To calculate the distances, we're going to use the selection lead, because this is for groups, remember? So let's check if he's valid. And we are going to be testing this against a navigation position that we calculated before, so we want to check that that is a valid. We have already assigned a valid position. And this will be index array for this loop. The current location is going to be the position, which is going to be this. And it's destination, I think. Sorry, outside the bracket, destination. And then we want to add to the total distance. So we're doing this for each group. Let's just copy this. So that's the distance to that position. So what we're doing there is this permutation will shuffle the positions, and this is getting what is the total distance now of our current result, and then we basically want to check if it's better. So we can go, if the total distance is less than our min total distance, which is huge on the first one, right? So it's the first one will always probably go through. And then if it did go through, then we want to update our min total distance with our total distance. And then if it is the best one, then we want to update our best array with our index, with the current shuffling of the index array. All right, and that'll go through until this returns false. And then, so let's do this function now. Bring this down. And this has to return bool, obviously. And it has to accept an int pointer to which we're going to call array. Which is our index array. And another int size. This isn't my code. I copied this from. This is actually something called the Hungarian algorithm, and you can look this up and have a read through. You can see here it's choosing the best combinations. That's essentially what it does by doing a bulk table. And I don't think it was from the wiki I got the actual C++ code, but I can't remember where, because a friend sent it to me originally, so it did give me the link, but I can't remember what it was, sorry, but you'll have it here in a second anyway, so. Oh, I just realised I did this all in line. I didn't mean to do that. I'm going to copy it. That was weird. Anyway, doesn't matter. So this can be made static. Fine. So that's the algorithm there. So it's just swapping out the positions and doing every combination of position. So I'm just going to put a few notes in here. These are my own notes, so I don't actually know if I've got this wrong, to be honest, but if you've seen me explaining something wrong here, please let me know. But I don't think it's too important to know exactly the details, to be honest. Just know that it's going through every position and doing the, the distance calculation, which it's using as a score. And that's generic. We'll be able to use this for the entities as well. So back up here when we're doing our assign selected positions, once we've gone through and we've got the best index, we want to go through our selections again. Okay. And we want to assign the selection with the best with its position that is from that best index array, so the best position for it. So what we're doing here is we're assigning the navigation positions owner, and it's going to be this selections group. So if you go to the navigation positions, we've got all these variables here. Sorry, that's not it. Formation position, here we are. So we've got owner, the source location, the actual selection that's assigned. So we're just assigning all that data here to the actual position that we generated. So this source position is the original position of the group. So basically where they are now before they move. So I don't think we've got a function for this. I'm not sure. So we need to get I think we might have a function for this, just not on the data. No, maybe not. I don't know. We'll just create one anyway. So we'll use it elsewhere as well. Oh, sorry, it's got to return a vector. We're just going to iterate the entities and get essentially an average position. I might just put in here. Any invalid entities will just be skipped then. And then we want to put in a check for that divide by 0 again. Yeah, and center position is greater than 0. Oh no, what is it? Sorry, the math, isn't it? It's not nearly 0. Did I have a not last time? Oh no, it's a vector, sorry. Yeah. So down here, this should be not. So if it's not nearly 0, then we do it. Right, sorry about that. I just realised that then. Oh, I've done it here as well. Alright. Yeah, we just need to divide that. Number of entities, and then return the center position. This is kind of not used, well, the center position's used, but we go back to where we're calling this somewhere. Yeah. This source position kind of not really used in our current setup, but if you're ever doing like an undo thing for movements, it'll definitely be used. I'm going to assign the selection here to this selection. Yeah, so that'll do there. So that's our position assigned. We now want to, now that we've assigned each group a position, the temporary position, we want to update the selection, update assigned formation positions with actual group position and spacing data. Going to be the same stuff going in. So we can copy some stuff here. So I'm going to grab this first. This. Actually, I think we will need the formation data on this one as well, sorry. That's the same as this one. And that will be the same. Because we're recalculating the formation essentially. And now we can copy we don't need to do this. We already have the left and right values. But we're going to want spacing again. So now, instead of looping over the selections, we're going to loop over our positions. That should be all. Something's gone wrong and we've stuffed up the navigation positions here. We're just going to skip it. So same as last time we did the positions, we're going to reset the local offset. And now we're going to want what we're going to do is we're going to assign it to the navigation, or we could just assign it to we'll put it on the navigation. So we just need the total selection spacing. Because we know the actual group that's there now, we can get the exact spacing that they'll need. So we can, check how much each entity needs. So this is in our fantastic drawings here. This is where we don't know which one of these is going to which position, but now we do. So we know that a 4-man group is going to the middle. We know that that's going to need, this much spacing now. Whereas before it could have been the 2-man, it would only need this much, something like that. So this position, the assigned selection, we're going to get now was this one going to work for us? Yep, so that's the actual spacing. I was making sure it wasn't the average spacing, but yep, that's the one we want. So that tells us the full spacing of this selection. So now we're back into sort of recreating our formation. So if it's going to look very familiar. It's going to have slight differences though. So here we don't need to check if there's a center, left or right, because we saved it, right? So we saved it in the position, so we can go, you could recalculate it all again, but it was easier just to, what am I doing? So here we're going to say, so we can just check the navigation position. I'm going to copy this because we're going to be just typing navigation.position all the time. So we can check the side that we saved, and if it's equal to that RTS center, then we've got a center position, right? So we can assign the center position is going to be in the center, like it's the position of the navigation, so we can just assign it. Which is probably what's already in, just typed it again, doesn't matter. Which is probably already in this position, but we're doing an update here, so we're going through everything. So that's the command's location, aka the center position. Now, if same as before, if we did have that center position, we want to add that spacing left and right now. So we could probably cheat and copy some stuff. I want this. Instead of just navigation selection spacing, it's going to be this spacing here. And actually we can update this group spacing as well. I'm going to add a variable for that because we're using an average on the other one, so we don't want to use that anymore. We want actual group spacing for the specific group that's assigned to this position. So I'll put that under selection spacing. That's updated. And then up here, we can do the same thing. So actually just duplicate this, change this to group spacing, and we'll get the selection, get selection. Do we have a function for that? I think we just had the average to me, so we're gonna create that. So get selection group spacing. Was this? Oh no, this is it here. Oh, we just called it get group spacing. There we go. So that updates the group spacing. So now we want to swap this with that. So if there's a center position now, we've just assigned the center position and we've calculated the left and right for the next position. I am just going to copy this twice. And then this will be left. This will be right. And then let's copy one of these. Where's left? So this, we can do, let's copy all of this. Don't want to add a position anymore, so we'll just, because we're just updating a position, but I think just copying this in, I just realized something. For the groups, it's a bit different. I'm going to have to, sorry, do my fancy artwork again here. So when we're assigning groups, so we've just calculated the first position, and that's in the center there. Rather than add a full position to, so what we just did was we added a full position based on this group's data, and that's not what we want to do. So each group has to calculate its own distances. So when we calculate this center group, what we want to do is we want to calculate half this group's distance. So it'll be this group's space it needs to fit all its entities plus the group spacing that this group has. So let's update this arrow. So this is entity spacing, and then this is the group spacing, and that's going to be on both sides. Can I flip this easy? Let's do that. There we go, I'll do. So that fits that group. So let's assume that group is 4 group, right? That almost got it perfect. So that's going to sit there like so with the group spacing. So we only want to add half and half on the left and right if we just assigned center position, which is not what this one is, but yeah. And then for the next position, the start point will be here. So the start point will be here. And we want to add the same again. So we want to go, okay, let's add the group spacing for this group over here and the spacing requirement for the entity. So let's just assume that this one's the smaller group. So it's only going to be like that. And then we assign, then we update the group position, and then we add the rest of the spacing again. So, and then that's the edge for the next group if there is one. And then we're doing the same on the other side, and that gets us the exact fit for each group with the correct group spacings. So, you know, like this group might be all tanks and it wants a group spacing of 400, and this might be infantry and it only wants 100, so we end up with 500 overall spacing. So let's fix what mistake we made there, and we just need to times these by 0.5. So we're adding half and half to each side. And then in here, we don't need this. We need this. Let's just copy this over the top. So we're adding half the spacing, and then again at the end, after we've assigned the position, we'll add half spacing again, which will update our spacing left distance. Here, we want to assign the position. So that's the group position plus the offset. And now we can, again, just copy all this for the right side and rename these. Oh, and take out the inversion, sorry. All right. And again, we're not alternating. We are basically going to do the same, but with the new spacing. So let's just type it out. So this is the spacing. And then for the position, we can actually do a check here. So if it's the first position, it's going to be the location. Otherwise, if it's not the first position, we're going to use the offset. So this one. And that now is our, all these can be static, by the way, but it doesn't really matter. So that's now our group positions done, and we've got the actual fixed group positions, proper, correct spacing for each group, etc., etc. So we're going to end this part here, but in the next part, we're going to do the same stuff, but put the entities in based on their spacing. I'll see you there. Thanks for watching.